Hello, in this video we'll cover some more examples using factorials. As before, 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. That was the basics of factorials. What happens if we try to combine them with rational expressions? For example, 6 factorial over 4 factorial. Well, here you may think you may need to multiply this whole thing out. 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1. But in actuality, a lot of these terms are going to cancel out. 4 and 4, 3 and 3, 2 and 2, and the 1 really doesn't do anything, but we'll cancel it out anyway. So in actuality, 6 factorial over 4 factorial is really just 6 times 5, which is 30. Let's try another example. Let's try 7 factorial over 5 factorial. Well, to save time, I'm not going to write this whole thing out, but I will write that 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, but I'm not going to write all that out. Instead of writing 5 times 4 times 3 times 2 times 1, I'm just going to write 5 factorial. And then the denominator is also 5 factorial. And again, I'm not going to write 5 times 4 times 3 times 2 times 1. So what's going to happen here, you guessed it, 5 factorial in the numerator is going to cancel with 5 factorial in the denominator. And we're left with simply 7 times 6 is 42. And you could go on and on like this. Let's try a ridiculous example. Let's try 100 factorial all over, say, 98 factorial. Now, if you were to actually try this out, you'd get something in the millions. But to save time, we're going to do 100 times 99 times 98 factorial. The 98 factorials will disappear, meaning they will cancel out, and we're left with 9,900. 9,900. So 100 factorial over 98 factorial is 9,900. Let's try a couple more examples. What happens if we were to have 6 factorial over 4 factorial 2 factorial? Now again, we're going to have to do some creative canceling. So just for the sake of showing everything, we're going to write the whole thing out as if we didn't know the previous trick. 6 times 5 times 4 times 3 times 2 times 1 all over. Now 4 factorial is 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. So now let's start canceling things out. The 4, the 3, the 2, and the 1, this was that 4 factorial that we had canceled earlier. 6 times 5 times 4 factorial is 6 factorial. But now what are we left with, this 2 and the 1? Well, here we can cancel, and if you remember your fraction rules, 6 is 3 times 2, so 6 in the numerator can cancel with 2 in the denominator. I'll cancel that 2, I'll cancel that 6, and I'll write a 3. In other words, I just factored out a 2 out of both numerator and denominator. And what are we left with? Well, this 1 in the denominator doesn't do anything for us. 3 times 5 in the numerator. So it's 15 over 1 equals 15. So 6 factorial over 4 factorial 2 factorial is 15. Let's try another example. How about 7 factorial all over 2 factorial 5 factorial? Now in this case we're going to use the shortcut that we learned earlier. So instead of writing 7 factorial out longhand, I'm just going to write the first few terms. 7 times 6 times 5 factorial. And the denominator is going to be 2 times 1 times 5 factorial. And now we're going to see what cancels. Well, 5 factorial will cancel with 5 factorial, and 2, like before, will cancel into 6 3 times. 6 is 2 times 3. We're canceling 2 out of numerator and denominator. This 1 doesn't serve any purpose. So our numerator is 7 times 3, or 21. So that just shows you a couple intermediate examples. We'll try one more. What if you were given a problem that looks like this? 6 times 5 times 4 factorial equals x factorial. And I hope you see what they're really asking for is, what is x? Well, 6 times 5 times 4 factorial, and again, let's just write it out longhand just to make sure you see the pattern. 4 factorial is 4 times 3 times 2 times 1. And so if this is x factorial, then x has to equal 6. 6 times 5 times 4 times 3 times 2 times 1 is equal to 6 factorial. And that's the basics of factorials.